So whatever equation we are saying for Newton law of gravitation, F is equal to G m1 m2 by r square is actually gives you the magnitude of force. Whereas to include direction of force, you have to include direction information also, and it is given by m1 m2 by r cube r cap with a negative sign. Negative sign indicates it is a attractive force. Whereas in the case of charges, it is repulsive force. When both charges are positive or when both charges are negative, magnitude of force is positive and force is repulsive. So there you don't need to introduce this negative sign. But because here it is attractive force, you have to introduce a negative sign here. Okay. So that is one correction here. So force is minus G m1 m2 by r square. Now, what is the potential? So ultimate test for attractive or repulsive potential is you have to calculate the potential. If the potential is negative, then it is attractive. If the potential energy is positive, it is repulsive. We have to confirm that, right? So here already we have a negative sign and force is minus del V. So what do you get? I mean, just for first initial observation gives an idea that potential is positive, right? Force and potential are related by a negative sign. So first assumption comes like it potential is positive, so it may be repulsive potential. So let us confirm that first. So how do you get potential? V is integral f dot dl with a negative sign. So you have to integrate over the distance with a negative sign. So what do you get? m1 m2 by r square dr with a negative sign. So it is plus g m1 m2 by r square dr. So what do you get? R square. So g m1 m2 r power minus 2.
Sir, class on the previous exams are met exams.
Okay. So it is gm1 into r power minus 2 dr. So x power n derivative n into x power n minus 1. So it is minus 2 g m1 m2 r power minus 1. So it is minus 2 g m1 m2 by r. So this is the potential. So we get a negative sign here. So if force has negative sign, since the variable is in denominator, even after integration, we'll get a negative sign. So this gravitational potential is negative. It is attractive. Okay. So now what is the direction of force? You have to consider a radial vector and take a direction opposite to it. So let's say you have two objects, m1 and m2, separated by a distance r12. It is vice versa. r12 is measured from 1 to 2, r21 is measured from 2 to 1. Okay. So now what is the direction of force? F is equal to g m1 m2 by, so f12 is So this force is proportional to R12 direction opposite. So R12 is in this direction. So force F12 will be in this direction. The same way F21, force applied by second object on one, will be in this direction. Okay. So you should be careful. This is only the magnitude, and the vector direction is given by this. So now comes the value of G. What you have, F is equal to G m1 m2 by r square, and I call it as mg. Let's say, so G value is G m1 by r square. Let's say if you have two objects, and for Earth this value of G is a constant and the value is 9.8 meters per second square. But here we have a variable, it is depending on r. Then how to conclude that? So G value is varying when you go away from Earth or when you go into the Earth, G value varies. So that should be taken care. So G value 9.8 comes only when you consider the surface of the Earth. It is a value on the surface of the Earth. So for those calculations we have to consider m as mass of the Earth and r as the radius of the Earth. Okay. So what are those values? Value of G is what?
6.674
6.674
into 10 power minus 11
into 10 power minus 11.
Newton
Okay, Newton meter
square by
per second square.
kgs.
Newton meter square per kg square is the unit of G. Okay, 6.674 into 10 power 11. Mass of Earth
5.972
5.972
into 10 power 24
10 power 24 kg.
kg.
And radius of Earth
6.31
6.31
into 10 power 6.
into 10 power 6 meters. Okay, so if you substitute all these values, you will get the value of 9.82 meters per second square. Okay, so G value is 9.8 only at the surface of the Earth, where R is equal to radius of the Earth, M is mass of the Earth. So I call that value as G naught, which is obtained by substituting mass of the Earth for M and radius of the Earth for R. I call that as G naught. And I want to see how it changes when I go away from the Earth and when I go into the Earth. So what happens when I go away from the Earth? Let's say this is the radius of the Earth, and I consider some distance away from the Earth as r. So then what happens? So the G value is given by Gm by r square.
R plus 1.
So this is r, total distance from the center of the Earth. Okay. So I have to connect these two.
Capital R కూడా consider చేయాలి.
I'm considering from the center of the Earth, total distance from the center of the Earth. I mean, if you are measuring, so here, let's say if you are measuring from the surface of the Earth, small r is equal to r plus h. Height of the object from the surface of the Earth. Okay. So in that case, what happens? I can relate these two as G is equal to Gm by r square by r square. I am introducing these two. So it is G naught times r square by r square. So as R increases, G value reduces quadratically. So the value reduces quadratically like this.
G.
Okay. What about going into Earth? When we go into the Earth, I mean R value is reducing, so G should increase. But still it decreases because the volume of the material that we are considering will reduce. So this is R, and when you are confining to a lower radius shell, you have to subtract this mass of the material. Now the contribution to gravity comes from only this sphere. You have to reduce the mass of the material within this larger sphere. So how to get that? So G is equal to mass. What is effective mass? Otherwise M. M is the variable here. I call this as M naught. So M is equal to M naught R cube by R cube. M naught into 4/3 pi R cube. Pi R cube. So I am dividing with the original volume and multiplying with the effective volume. Okay, I am considering the fraction of it. So it is M naught R cube by R cube. So that is the new mass for which we need to calculate G. So G is equal to Gm by R square, which is G times M naught R cube by R cube R square. And for small r, we have to substitute this. Somewhere if you divide and multiply, yeah, so this can be written as so G is equal to G M naught by R square R by R. Which is G naught R by R. So it is the value of G naught multiplied by R, so it reduces linearly. So this is R, below the radius it reduces linearly, above the radius it reduces quadratically. G value as a function of R. Okay. So that is how G value varies. It is purely depending on the distance of the object from the first object. right? So for satellites, you'll have a different number. For object on a tree, you'll have a different number. Like that, I can manipulate the value of g depending on the height.